Hello, everyone. Thank you. Thank you so much for having me here. Today, I'm going to talk about a topic which is really important in terms of being able to adopt AI solutions in the real world, right? And this is something I would say we learned as a team at events team very I would say the hard way, right? So I would ask to the folks present here, right? Like, how many of you all have actually worked with AI agents or tried to deploy them in production? So you guys know how much of a nightmare it is to get a reliable output. Do you guys agree with that? Right? And we come from like pre-AI, we come from a world which is very deterministic, right? And what does deterministic mean is it's a computer, and what I say to do, that is what it does, right? So everybody, including your non-coders to your coders, are very used to that sort of paradigm. But now with AI agents and AI kind of like taking a lot of the center stage in big applications, it has become very non-deterministic. There's a very popular definition of insanity, right? And it says that doing the same thing over and over again and expecting a different results, that is commonly referred to as insanity. But friends, that is what we are doing with AI. Right? So the task that we wanted to solve for is content generation. And in content generation, it's a big aspect where everybody thinks, oh, wow, LLM can generate content, it can generate blog posts, it can generate social media posts. But what nobody realizes is for that particular engine to fit into an autonomous system, a system that is going to be running without any interventions, to be running again and again on multiple and generating like a pipeline and sort of a factory of content creation, it is not at all reliable. And that is primarily because you don't know what it's going to create, right? And once it has created it, you always want a human in the loop. So what does human in the loop mean, right? I feel like there was a question here today about what is human in the loop. So human in the loop commonly refers to as a human who is going to be taking a decision of an accountability of sorts of whether this output is good enough to put my brand name on it, right? So whether it is for personal use, whether it's for IBM, whether it's for any big events such as Wimbledon or US Open, if they are posting any content, it is on them and their accountability and their expectation of that level of event they are, that what they are posting is accurate, is something that is relevant, and something that everybody wants to know about, and something that they are willing to easily be able to put forth, right? So that is where human in the loop comes into picture, where if there's an autonomous system that is generating this content, this human in the loop is going to validate this, read through this, sort of like an editor, where he or she is modifying the content, making sure it is good enough, and if it is not good enough, rejecting it, right? This is not good enough quality, this is not the brand, this is not the brand aesthetics that we want to go with, so we will not be posting this, right? Something that sort of wall of human intervention, that is what our human in the loop is going to be doing. Now, the problem statement that we are working with starts there, where we want the AI to be more and more reliable, to be able to generate content that does not need so many iterations, does not need to be modified and be like, oh, no, 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 this is not what I meant. Please generate again, or remove this point. This is not good. Tell me some other ideas. So this sort of back and forth is something that we do a lot in on ChatGPT, on Perplexity, and all the other chat assistants. But in an autonomous system where we are writing code for an agent to be able to do this, we want that to happen autonomously as well. Now, So what we want, right? What we want that we want to get to the required output with as many less tries as we can. The next thing we want is, we know nothing is perfect, right? Like how much ever we say, okay, do it again, we still be expecting that there might be need to be a human, there might need to be any manual edits required for it to be of quality content, but we want it to be minimal, right? We want it to decrease the amount of effort it takes. And then why are we trying to do this in the first place? One of the reasons why we do this is faster content generation, right? Like imagine there's a tennis match. Now this Yannick Sinner and Alcaraz, right? They have gone and hashed it out on the court. Everybody is engrossed. It's been like 6 hours, and the match has ended with a phenomenal win for either one of the players. Now there are people who and fans who love tennis who are able to come together and watch it live, enjoy that action. But there are a lot of other fans who, for whatever reasons, probably attending this summit today, are not able to watch the match live, right? So the organizations and media houses generate blog posts and different types of content. A typical time it takes to generate a content post any match is 3 to 4 hours. That is because the editors and the journalists are going through the whole match, trying to identify, okay, what was nice, what can we talk about? And because it's not going to be a huge novel, it's going to be a small piece where they want to highlight the key moments, the key times in which the match shifted, and at the same time, they want to make it engaging enough for fans to be able to read it. So that is what takes, like, I would say 3 to 4 hours, and then you will take another 30 to 45 minutes where they go through an editor cycle, and then the chief editor edits it and makes it available. So for an average fan, that's like 4 or 5 hours. That is history today, right? Like in social media, we are used to things coming in a snap. So we don't want to wait 5 hours after the match has ended to know what actually happened. So this is where we want to, that is why we want this AI system, and that is where this AI system will be helpful. Now, how do we solve for it, right? The way we are solving for it is, I would split it in 3 phases, right? First is the content generation part, where we want to make sure that the first content that we create is actually good enough, right? And for this, we'll be leveraging something called a chain of thought reasoning. And to give you an example of what does chain of thought mean, right? So if you give any large language model a prompt, something like this, where you're saying, write a 2-sentence product that describes a smartwatch for kids, right? Now, this particular prompt is good, but it's not good enough that the LLM may or may not work with giving the desired output, right? It would give something very generic, something like, this is a smartwatch, it's colorful, fun for kids to use it, you know? But next, what we're going to do is we're going to add something called chain of thought, where we force the LLM to explain your steps. So that is the only change we are going to do. It's a very subtle change, but a very impactful change that can be done to any of the prompts that you're trying to use, where you add this thing called explain your steps. Now, in this steps, when LLM is trying to generate and predict the next word, it is creating a reasoning and in turn making the content better for itself. So when it generates, like, okay, so we want to generate a product. The product is smartwatch for kids. And what are the key requirements? We want it to be focused on safety. We want to make it sound fun. Now, what does safety mean, right? Safety means GPS tracking, parental alerts. And what does fun means? Games, colorful colors. That is something that it attributes as fun. And then using all of these, it generates a much better output. Now, there are 2 things that happens with such a explanation. Number one is you get by far a much better output. But number 2 is you get explainability. You understand what is going on and why this particular result has come. So for example, if we do not like this output, we know what to change. We want to describe what fun means. So if we say, oh, he's saying the LLM is considering fun as games and colorful design, but that is not fun is. Fun is probably something else based on the definition of the product itself. or we want to introduce characters or designs of sorts which are more specific to the watch and the product. So we know to go back on the prompt and modify it in such a way that we can get a more reliable output. So it works in two ways, where it helps in creating better content, but at the same time it also helps you debug and create a better prompt, right? So one of the things that we were talking about earlier in one of the sessions is how do we so that we should not we are not machines, humans are not machines, right? And I agree with that completely, no wonder, right? But I'll tell this, where there's a caveat to it, is that when you're designing AI systems and when you're designing prompts such as this, it's important to think that you are a machine, right? I'm definitely contradicting here, but it's just to understand that for an LLM, if you are an LLM and you are given this prompt to think about what to create, will you be able to do that with that limited information? If not, then add more information to the prompt that is going to help you create the desired output. That is going to make help you use this technology so much more better and easier. So the next part is so now we have generated the content, right? Now we are to some extent much better from where we started for content generation. The next thing is we want to evaluate the content. Now, content evaluation is again a really important aspect. Now, if I go and ask to the stakeholders, to the editors, what are you looking for in content? They'll say X, Y, Z. But when I give that prompt to the LLM, like, hey, generate a content that satisfied X, Y, Z, I take it back to them like, it's not right. Maybe we can do this. Maybe we can do that. So what I'm trying to say is that no editor and no human is able to tell what they want. Like one of the things that Steve Jobs says is, customer does not know what is right, right? So that is primarily coming from the fact that it's not very easy to articulate what people want. And that is where we ended up trying to create a judge that is going to convert the qualitative aspects of what is important for content generation into quantitative way, such that we can make decisions on top of it. So we came up with a prompt that looks like this, where we are defining parameters in terms of what is it that we are looking for. We want the facts to be right. We know LLMs tend to hallucinate. We want to make sure that the output that we are producing is factually correct. If Alcaraz has won the game, we don't want LLM to create content about Sinner winning the game, right? And then the next part is novelty score. Now, this is the reason we separate this factualness and novelty is we like creativity. We like when an editor or when a journalist comes up with their own way of explaining something that has happened. So we like novelty, but what we don't want it to come at the cost of factualness, where you are now misrepresenting the facts. So that is where we use something called as the novelty score. And in this novelty score, we want to make sure that the content that is produced is actually is new, but then at a certain threshold where it is new to be creative enough, but not as new that we don't know what is happening now. Now, next two is relevance and repetitive. Now, relevance is where we want to make sure that it is sticking to facts, it is sticking to the information that is actually available and relevant to the game of the tennis in this situation, and it can be applied to anything that you're generating. Repetitiveness, this is something that we had to add primarily for long form content. So when we did this activity for more than one type of content generation. So when we did for small content where we're creating 3 bullet points of sorts, it was much easier and it was giving a really good output. But when we moved on to a more long form content where we asked it to generate like paragraphs, it started to repeat the same thing, like trying to make sure that the factualness score is correct and there's like it's more relevant. It just said Sinner served the best. Sinner served at a max average speed of 160 kilometers per hour, and then in the next slide it said 160 kilometers hours. Sinner serve speed was had a great advantage against Alcaraz. Now this is where it starts to repeat the same facts, and nobody wants to read repetitive stuff. So this is again something that we had to add more, I would say, empirically than theoretically. And this is what the output looks like, right? So in this, the context, that is the individual facts that we gave it, which is more of a templatized structure of what the output and what has happened in the match. And we use a lot of our maths and statistics to identify what is relevant and what we would be calling it as important enough to be referred to in a blog post, right? And not create a big amount of noise for the large language model to choose from. And then the paragraph is what it generated, right? Then finally, the LLM as a judge was able to output, hey, this is factually correct. So I'll give it 100%, 100 score. And then it explains why each and every score is given and what is the reason it has deducted any score if it did. Now, this helps us tune this prompt and tune the definition of parameters over here such that it is actually reflecting what we want to see. Next, now, okay, so now we have this content, we have this judge who has told us, hey, this is not right, this is right, and things like that. Now, what do we do from there? So this is where we start to use some of the theory of mind prompting, as we want to call it. And what does this mean? Is we take historical editors. So we ask our human editors and our human in the loop folks to assist us in this aspect, where we take all the generated content for 2023, right, of US Open, and then we ask them to review it, approve it, or edit it in terms of what they seem fit to be presentable to the website. And then we use that output as our basis to create some sort of a memory mind of sorts, where we are not asking the humans what you expect, what you do not expect, but instead using our LLM as a judge to create baselines, to create expectation values that are acceptable to be approved by the human in the loop. So what does that do? That means, so once your AI content is created, we have our judge evaluating it. And then next part is where we want to do an editor correction here and make sure that it is good and ready for human approval. Now, how do we do that? So then this is what we use as a next step in our AI agent, where we ask it to behave as an editor and use the same parameters to evaluate, to edit it. But now we are giving it a feedback, say, hey, this is the paragraph you gave, but it is not good in terms of factualness. It is not good in terms of novelty. We wanted to change, we wanted to change the relevance or topic alignment. So that is where we use this feedback to be able to ask the LLM to edit this response. Now, many of you folks might be wondering, like, so you're saying 5% increase the factualness by 20%, decrease the factualness by 20%. What does that mean, right? Like, how will anybody interpret it? Now, the reason why this works is because of the definition of parameters. And we have this is what we get, where we are able to identify, and the way we run it is we run it 21 times. We have a max iteration of 20 times. We wanted to keep doing it until and unless a convergence is reached. What is convergence? It needs to be in the required threshold of expectations. Okay, this is good enough content to be used later. The first column over here talks about initial assessment. That is where we started with the content generation. And this, I do not have the numbers of before we used chain of thought prompting, but it was much worse, where the factualness was off the charts, the repetitiveness was off the charts. But then with initial assessment, with chain of thought prompting, we started off from a really good baseline where we have like very low factualness, but we have very high novelty, right? And that was something that was not acceptable to a lot of the stakeholders. So we run our 2-minute, within 2 minutes, run the 20 iterations. This was all done on the What's the Next platform. And with that, we were able to get some of them were converging, where it meet exactly the expectations, and hence we have 0.0 difference in all these parameters, versus some of them will not. And the average scores are reflective of what the output is. And even when things are not converging, what we observed in our data is that it would go back and forth. So it would edit. It's very difficult to sort of come to a balance between factualness and novelty, and some of the times even relevance, because these things are not mutually exclusive of each other. You cannot decrease one without compromising the other. So that is where LLM would go into a loop where it would edit something and then come back and add the same thing in the next iteration. So it would keep doing this back and forth for a couple of times. And then suddenly in the fifth try, it would do something completely novel and learn from all its multiple iteration steps, and then suddenly converge to the expectations. So what we observed was it would create multiple new iterations, and then immediately use all of that to create an output that would satisfy everything. That is how I would say a lot of human editors would work, right? Like you try bunch of things, and then you pick the best one out of all the iterations, mix and match. So that is what we ended up doing. So yep, that is what I have for today. Any questions?